Chapter 1. Yeah. This is... In theory, this should be the easiest portion of the year because everything we're doing now is stuff we've done in Algebra and Algebra 2. We're not learning anything really new. We're just reinforcing ideas. That being said, some people really decline in these next couple sections. Some people think it's really easy, so they don't have to study for stuff, and then they fail the test. Other people are like, oh, I saw this in Algebra 2, it was really hard, so I quit to begin with, and then you do really bad on the test. My advice to you is go with my pace, pay attention to what I'm doing, and do all your homework as best to your ability. Quitting and thinking it's too easy are the two pitfalls in this section. You do that, and you're going to do poorly on the test. All right, that being said, we have three names up there. We have identity, we have conditional, and we have inconsistent. So we actually limited them down to even smaller than we went to in the beginning. Identity. Identity is something that all solutions will work for. In other words, no matter what I plug into one side, the other side will stay balanced. In an identity, if you are solving an equation, you're going to know you have an identity because you'll either have the same thing on both sides. So you're looking for is the same thing on both sides, or you might come down to a statement that's like 3 equals 3, which would be a true statement. You have an identity. So either both sides are the exact same, or you whittle it down to something that's a true statement. Conditional is satisfied by at least one solution. At least one value makes the statement true. When you are solving an equation, you're going to come up with something that says like x equals 3. That's a bold statement. All right, come up with something that's like x equals 3. Finally, we have inconsistent. That means there's no solution. Nothing will work in it. This will be an untrue statement. It might say something like 3 equals 2. That would be false, so it would be inconsistent. I'm going to talk about inconsistent really quick. There are more cases where it's inconsistent. There is something called an extraneous solution. It will be, when you solve your equation, you'll come up to like x equals 2, but when you plug it back in, it actually doesn't work in the equation. That is something called an extraneous solution. It is a false solution. You think it works, but it does not. The big sign that you might have an extraneous solution is there will be a variable in the denominator. A variable in the denominator is a good opportunity for you to check to see if it has an extraneous solution. And we will have one of those cases in the examples. All right, we're just going to go through some examples, just a rough rehash on how to solve systems. Not really systems, but just equations. All right, the main focus of today is how to get rid of fractions, because a lot of us are really terrible at dealing with fractions. So the quicker we can get rid of it, the easier it is for most people. This one, you can solve it with the fractions in there. This one, you really can't. You'd have to get rid of the fractions. So we're going to get rid of the fractions on this one so we can see how it is there. The way we're going to get rid of fractions is we're going to find the lowest common denominator. That means I'm looking for a number that 2 and 4 both go into, and I'm going to multiply it by that. So I'm going to look for our lowest common divisor, and in this case, it's going to be 4. So I'm going to take that 4, I'm going to multiply both sides times 4, remembering that I'm multiplying everything by 4. I do want to preface this, you do not need to do it this method. You can just use subtracting fractions and stuff on this one. So you could just add 6 to both sides, subtract 3 over 4, and then multiply it. We're just setting up for the next one. All right, so if I multiply everything by 4, I have 4 times 1/2, which will leave me with 2x minus 24. 4 times 3/4 is just 3x. And 4 times 9 is going to be 37. Oof, no, 36. Ugh, long day. Long day. All right, so now what we're going to do is we're going to get our x's on one side, and we're going to get all our numbers on the other side. So in this case, I would subtract 2x from both sides. And then we're going to go ahead and add 36. to both sides. That way we're going to have 2x minus 2x, which is going to equal 0. Negative 24 plus 36 is going to be 12. That's going to leave me with x. Negative 36 plus 36 is 0. So we're just left with x equals 12. That means we have a conditional. That is at least one solution. All right, questions on that? There are multiple ways to solve these. I'm just showing you how to get rid of fractions if you really hate them. The next one, we do have to get rid of fractions. That means we're going to come up with a common divisor. Normally it's called the local common divisor. But in this case, we don't know the lowest. We don't know it's actually the lowest common divisor. We just know it's a common divisor. So I do call this just the common divisor. And that is multiply all of your denominators together and you will get a common divisor. Might not be your lowest, but it will always work. So my common divisor will be multiplying all of our denominators. So that would be 2 times x minus 1. And we're going to do the same thing by multiplying everything by that common divisor. So we're going to multiply everything by that 2 times x minus 1. I'm going to change that multiplication sign to just a dot because that's 2 x's in a row and I don't like that. Okay. We're multiplying everything by that 2 times quantity x minus 1. Remember to distribute to everything. So when I distribute it, 2 times the quantity x minus 1 times 1 is 2 times the quantity x minus 1. That's going to equal 2 times the quantity x minus 1 all over 2. And finally, 2 times the quantity x minus 1 times 1 over the quantity x minus 1 is going to equal 2 quantity x minus 1 all over quantity x minus 1. If you're suave about this, you can probably get away with not showing all of that work. Because what's going to happen next is our 2's will cancel out in the first fraction, and our x minus 1's will cancel out in our second one. That's going to leave us with, well, let's distribute this 2 to both the x and the negative 1. We will have 2x minus 2 is going to equal x minus 1 plus 2. Bless you. Well, I really don't need those parentheses because it's just a positive out front. So we really don't need those parentheses because nothing can change inside of those. So now we can just go right to subtracting x from both sides and doing that math. So let's subtract x from both sides and simplify. So we're going to have x minus 2 on this side. Negative 1 plus 2 would be a positive 1. Add 2 to both sides, and we're going to come up with x equals 3. This is one where I'm going to check to make sure it works, especially because this could be an extraneous solution. So what I would do is I would plug this 3 into here. If this is problematic, then it might not be a solution. Well, if I plug a 3 in here, we'd have 3 minus 1, which would be 2. 1/2 plus 1/2 does equal 1. That is okay. This is a conditional equation. Our next one isn't super interesting. It doesn't have any cool fractions in it. Nothing cool is going to happen. But I do want to talk about distributing a binomial times a binomial. And that's because people still struggle with multiplying binomials times binomials. I know you've heard like FOIL and what you're supposed to do when you see a binomial times binomial. I'm going to do what I do all the time in my head. So first of all, let's start with distributing the left-hand side. So that means I'm going to distribute that 3 to both items. So that's going to be 3x minus 3. Then I have to take this negative 2x and distribute it to both of these numbers. Make sure you're distributing the entire negative 2x to both. So that's going to be a negative 8x. Negative times a negative is a positive 2x squared. Here's how I treat binomials, and this is why I treat it this way, because this works for trinomials times trinomials, this works for trinomials times binomials, it works for any number of terms times any other numbered term. What you're going to do is you're going to take your first term, in whatever you have, in this case it's a binomial, and distribute to both items of the other thing. So if this was a trinomial, I would distribute to that third term as well. In this case, it's just a binomial times a binomial, so we'll have 2x times x, which will be 2x squared, and 2x times a negative 3, which is a negative 6x. Then we're going to take that positive 1, and we're going to distribute to both items as well. So we take the first term, distribute to everything that's in the other one, and then take the second term and distribute to everything that's over there. So that's going to be 1x plus 1x minus 3. Well, if I simplify the left-hand side, we're going to end up with 2x squared. We're going to have negative 8x plus 3x is a negative 5x. And then we'll have minus 3. On the right-hand side, we'll have 2x squared. Negative 6x plus 1x is negative 5x minus 3. I can stop right there if you want to. Note that it is the same on both sides. Both sides are the exact same. That means it has to be an identity. It's the same thing on either side. No matter what I plug in for x, I could plug in a 2, and it would be the same on both sides. If you did not catch that, you would have worked your way down, and you would have ended up with probably a negative 3 equals a negative 3, which would have been a true statement. Well, a true statement and having the same thing on both sides lead us both to saying that this is an identity. You can stop at any place. If you notice the same thing on both sides, you can go ahead and say it's an identity, or you can continue solving and come up with a true statement and saying, okay, now I know for a fact it's an identity. Okay, next one. Well, there's only one denominator, so I don't need to come up with a common denominator. I'm just going to multiply both sides by that y minus 3 to get rid of those fractions. So once again, to get rid of these fractions, I'm just going to multiply both sides by quantity y minus 3. Well, we're going to distribute to everything. And so we're going to have y minus 3 times y. I'm going to put the y out front. All over y minus 3. Plus 3 times that quantity would be 3 times y minus 3. And that's going to equal, our numerator's 3, so it's going to be 3 times that quantity, y minus 3 on top, divided by y minus 3. Then I'm going to cancel out anything that has itself over itself. So in that y times y minus 3 over y minus 3, the y minus 3 divided by y minus 3 turned to 1. So I'm just left with y. Not equals, but plus, because now we have to distribute that 3 to everything. So we're going to have plus 3y minus 9 is going to equal, once again, the y minus 3 will cancel out with the y minus 3, so I just have it equals 3. Y plus 3y is going to be 4y. I'm going to add 9 to both sides, so 4y equals 12. Divide both sides by 4, and we're going to have y equals 3. If you would circle this and write is conditional, you would have minus 2 on the test. This is not a conditional equation. There's actually no solutions to this problem. And why there are no solutions to this problem is there is a variable in the denominator. So if I was checking my answer, as we should on all of them, I know I'm not taking the time to do that, you can do that on your own. If I was checking my answer, I'd be replacing all my y's with 3's. That would give me 3 over 3 minus 3 plus 3 equals 3 over 3 minus 3. Well, if I go further, we would have 3 over 0 plus 3 equals 3 over 0. That's a huge problem. 3 over 0 and 3 over 0 are undefined. Which means 3 is an extraneous solution. It's extraneous because it's basically a trick. It's false gold. It doesn't work. It looks like it will, but it won't work. So 3 is an extraneous solution. Extraneous, is that right? I feel like that's spelled wrong. Okay, it just feels wrong. Maybe it's because it's in green. It's an extraneous solution, and since there is no other solution, it means that there's no solutions, and so it's inconsistent. So this would be If you have two solutions and one's extraneous and the other one is not, then it would be conditional. Yeah?
Could you also solve it by taking 3 over y minus 3 and subtracting it from both sides?
Say that one more time.
Could you also subtract 3 over y minus 3 from both sides?
Yes.
And then have y minus 3 over y minus 3?
Mm-hmm. Yep. A lot of these have multiple ways. This is just like the easiest, just get rid of fractions. It's kind of that, bazooka for solving problems. Because it seems like as soon as you get rid of fractions, it is like a bazooka. It's not always the easiest, but it'll almost always work. It's very efficient, and it gets rid of the problem, as long as you know what's going on. Okay, so that one's inconsistent. Okay, our next one. You could take the time and multiply all of these denominators together. What might be something easier to multiply both sides by? That wouldn't be all 3 of your denominators multiplied together. Aaron?
You did x minus 1 times x plus 1.
Yep. That's exactly right. We just have to multiply both sides by x minus 1 times x plus 1. So I'm going to put a big note on here. Check this on every time you have a problem like this. In this case, x squared minus 1 actually equals x minus 1 times x plus 1. It's a difference of squares. So in fact, it's x squared minus 1 squared. Since that already equals it, I just have to multiply both sides by this x minus 1 times x plus 1, and it will get rid of all of our fractions. So that's exactly what I'm going to do. I'm going to take this, and I'm going to multiply by x minus 1 times x plus 1. Now let's distribute this. Well, when I distribute it here, rather than keeping that form, I'm going to write it as 2 times x squared minus 1. So I'm going to put it as an alternate form so I can see what cancels out. So that'll be over that x squared minus 1. That's going to equal, let's distribute to both of these. So we would have x minus 1 times x plus 1 all over x minus 1. And then we're going to have minus quantity x minus 1 times x plus 1 all over x plus 1. Cool. Let's cancel out some stuff. So in that first 2x squared minus 1 over x squared minus 1, the x squared minus 1s will cancel out. I'm just left with that 2. In our next one, our x minus 1s will cancel out. And I'm left with x plus 1. In the other one, our x plus 1s will cancel out. And we're going to lead us to what 50% of you are going to do wrong, at least. There's a negative 1 outside of a quantity. A negative 1 outside a quantity needs to be distributed to the entire quantity. So that means I need to distribute this negative to both the x and the negative 1. True story. Every time you get rid of a set of parentheses, you're always distributing by something. So if you look here, I have a positive 1 out front here. So in reality, to get rid of those fractions, I'm actually distributing a positive 1 to both things. Normally don't do it because it doesn't change anything. But we are always distributing something to get rid of a set of parentheses. So that's going to leave us with 2 equals, well, that's just x plus 1 minus x plus 1. Well, our x's will cancel each other out, and I'm left with 2 equals 2. That is a true statement, and so it's going to be an identity. Historically, if I put 1 on this to test, a good majority of people get 1 out of 4 points for it. Because the majority of people will just forget to study this stuff, multiply all of those denominators together, and mess that up. And they'll also mess up distributing that negative sign, which are 2 mistakes, which gives you a 1 out of 4. So make sure you understand basically what we're doing with our denominators, what's crossing stuff out, and also remember, if you have a negative sign, that you distribute it to everything. All right, the very last thing we're going to talk about today is absolute values. Absolute values are distances away from 0. How far a number is away from 0. Distances are always positive. That's why you'll always notice that absolute values result in a positive number. Well, this first one says if you have an absolute value of x equals k, where k is positive, k is 2, 3, 4, 5, 6, 7, 8, whatever, then x can either be k or x can be negative k. In other words, if our k is 4, absolute value of 4 equals 4, but the absolute value of negative 4 also equals 4. So our absolute value will result in 2 possible answers. When our absolute value equals 0, there's just one answer. That has to be just 0. And finally, if your absolute value ever equals k, where k is a negative number, if I put that on a test or something, you just put down no. You can't do it. An absolute value can never be negative. So if I say the absolute value of x equals a negative 2, you can't do it. Don't try to solve it, because that's a waste of time and you lose a bunch of points on the test. Absolute values can never equal a negative number. All right. Generally speaking, most people get this first one right on a test. So if I put this one on a test, most people after this example will be able to get it correct. Well, if this answer is 4, that means this inside can equal a positive 4, because the absolute value of 4 would equal 4. But this inside can also equal a negative 4, because the absolute value of a negative 4 equals 4. So to get rid of our absolute value signs, we're going to split into 2 possible equations. Either x minus 5 equals a negative 4, or x minus 5 equals a positive 4. For the left-hand side, we'll add 5 to both sides. We'll have x equals 1, or x equals 9. And if you plug those numbers in, if I plug a 1 in here, 1 minus 5 is negative 4. Absolute value of negative 4 is 4. 9 minus 5 is a positive 4. Absolute value of positive 4 is 4. This next one is where a lot of people are going to get it wrong. You can't split this into 2 equations yet. You have to have it in this form. You have to have an absolute value all by itself and something else on the other side, usually a number. So as soon as you get an absolute value, you need to get the absolute value portion by itself. That needs to be alone. You need to get that by itself. So you're going to treat it almost like a variable in itself. And that means I'm going to add 6 to both sides to get rid of that negative 6 on this side. Then I would divide both sides by 2 to get rid of that 2. And now you're going to see you have absolute value of x plus 8 equals 3. That means that inside section can equal a negative 3 or a positive 3, and it would work out. So only when it's by itself can you split it. Now we can split it into either x plus 8 equals a negative 3, That doesn't look like a 3. That looks more like a 3. Or x plus 8 equals a positive 3. Well, for the first one, we'll have x equals a negative 11. Or x equals a negative 5. And to check this, you'd plug it back into the original equation, and you can check it on your own. It does work. Both of those numbers are correct. Yes, Liv.
Can you put the answers in, like, with the
Yep.
side?
Kind of like I had over here.
Yep.
Okay. So, basic stuff. But once again, if you are just taking this foolhardily, you're going to be terrible on this test. If you're like, meh, I've seen this before, I'll just, do half the homeworks, I could figure this out. You need the practice. Trust me, you need the practice. You need to go through these homeworks. All right, 2 big things. Test corrections due at the end of the period tomorrow, or end of the day tomorrow. When I leave, that's it. Secondly, if you did not take that quiz yesterday, you have to meet with me to take that quiz. Otherwise, you're going to get a 0 out of 30 for your homeworks. And everyone's here, so that's your warning if you weren't here. All right. The rest of the time is yours to work.